Hey guys, Mr. Milton here. Today we are going to talk about multiplication properties of exponents, number 2, so some added things. At the end of this video you should be able to use multiplication properties of exponents to simplify exponential expressions, and you should be able to differentiate between the various properties and use them accurately to simplify expressions. Okay, so reminder from last lesson. If we had a to the m times a to the n, we would get a to the m plus n. Okay, so notice there's one base. Base is a, stays a. The exponents are whatever m plus n is. Okay, so if we had 6 and 3, it'd be a to the 6 plus 3 or a to the 9. Okay, so that's the rule from last lesson. Now, adding to that, or a little bit different from that though, we're going to rewrite the following expression so that the property above can be used. We have x to the 4th cubed. Okay, x to the 4th to the 3rd power. Okay, and so we're going to rewrite that. X to the 4th 3 times. Okay, so using the old property, we know that this simplifies to x to the 4th plus x to the 4th plus x to the 4th plus 4 plus 4. Just 8, 12. X to the 12th. Okay, notice the base stays the same. Okay, now here's the shortcut. Shortcut is that when we raise a power to a power, because that's what we did, we had a power, 4th power, x to the 4th power, and we raised it to a power. Okay, when we raise the power to a power, we multiply. Okay, so here, how many bases do we have? Still stays a as the base. How many exponents do we have? Whatever m times n is. So if we have a to the 6th to the 3rd power, it would be 6 times 3, which is 18. Okay. The thing that I want to make sure that we see here is that we still don't change the base. Our base remains the same here. Okay, a lot of times people will try to change that. Do not do that. Alright, so here we go. Let's go through some sample problems here, example problems, practice. Bottom here we have 3 to the 5th to the 4th power. So, again, we take this, essentially, taking this exponent and multiplying it by the exponents inside. So you have 3, base stays the same, to the 20th power. Works with variables as well as the base. B to the negative 4th power to the negative 2nd power. Okay, we're going to take this and distribute to the exponents inside. So B, negative 4 times negative 2, 8. B to the 8th. Number 3, m to the 6th times m to the 4th. Notice that this is different than 1 and 2. 1 and 2 are raising a power to a power. 3, this is just multiplication. So we have m to the 6th plus to the negative 4. So that gives us m squared. Move this up just a little bit here. Okay. Alright, now we're raising a power to a power again, so we're going to distribute this power to the terms inside. We have c to the 5th times negative 3, and that gives us c to the negative 15th. Okay, now remember in our final answer we do not want a negative exponent, and so we'll make it positive by moving it to the denominator. So 1 over c to the 15th. Number 5. Now it's a mixture. We have to both raise a power to a power, so k to the 6th squared gives us k to the 12th. And then we also have to multiply k to the 12th times k to the 5th. So when we do that, remember that shortcut was k to the 12th plus 5, k to the 17th power. Alright, Alright, so try number 6 on your own. Have that for me. Okay, using the same rules as we've done up to that point. Alright, on to the back. What happens when there are more in the parentheses? So before we were just dealing with one variable or one term in the parentheses. What if there's more in there? So let's see. We're going to rewrite this expression, 5x cubed squared. Rewrite it so we can see the rules that we've already established and see how they work out for us. Okay, so we have 5x cubed times 5x cubed. Well, like we did last time, we're going to kind of regroup this. This simplifies. I'm going to group 5 and 5. 5 times 5 is 25. Okay, and then I'm going to group my x cubes together. X cubed times x cubed is x, 3 plus 3 to the 6th. Okay, so trick for remembering this is make sure that each term or each number, we'll say term, has an exponent before you multiply. So what you could do here to help yourself out essentially is we went from 5 to x. X is not a exponent, so we went 5. 1 is the exponent for 5. And so what we're going to do is we're going to distribute, like I've been saying, this exponent on the outside to the exponents inside. 5 squared times x to the third squared. So x to the 6th. Okay, so let's see how that works out for us. So here we have 2z to the 4th power. I want to make sure that each thing has an exponent. Okay, and then I'm going to distribute to this exponent. So I have 2 to the 4th, z to the 4th. And make sure but each of these has an exponent. G to the negative 5th, already an exponent. So I have 3 squared, g to the negative 10th. Okay. Now, that can't be my final answer. I have a negative exponent, so I need to move g to the denominator. I'm going to circle it since I have it off. So 3 squared over g to the 10th. Okay, number 3, 2. Need to make sure that has an exponent. When there's no exponent written, remember that the exponent's 1. So 2 cubed. And then t to the 0 is just 1, so we don't need to write it because 2 cubed times 1 is just 1. Okay, so we can have it 2 cubed or we can change it to 8. Okay. Number 4, we have 2t cubed to the 0 power. Now here we go. Remember that anything to the 0 power is just 1. So 2t cubed to the 0 power is just 1. Okay, now we get to some more intricate problems. So c squared to the 3rd, c to the 6th. Okay, make sure this has an exponent. 3 cubed c to the 15th. I'll group these c's together. So I have 3 cubed c to the 21st. 15 plus 6 is 21. Alright. I'm going to do 6 as the last one that I'm going to do here. Make sure that has a variable, exponent, exponent, exponent. Okay. Distribute. So I have 2 to the 5th, a to the 15th. 3 cubed, a cubed, b to the 6th. Okay. Now, what I'm going to do is I'm going to put these together. Gives me a to the 18th. Kind of regroup these. 2 to the 5th, 3 to the 3rd, a to the 18th, b to the 6th. Alright, now the reason I did this is because our numbers, although we can't use a shortcut to do this, we can simplify this. Okay, 3 to the 3rd is 27, 2 to the 5th is 32, 32 times 27, what I should do, 864. Okay, and so I have 864, a to the 18th, b to the 6th. Okay. Lastly, at the bottom, well, actually, I want you guys to do 7 and 8. Last for this note, bottom of this page. If we're doing scientific notation, we will do the same thing. Okay, when we raise a power to a power, we're going to distribute this to each term. Okay, so I have 3.1 squared times 10 to the 16th. That's pretty easy. So 3.1 squared, 9.61 times 10 to the 16th. Okay, and you do that last one. Okay, so there's 4 problems that you should do to make sure that you understand what the rules are. Okay, scientific notation is essentially the same. So hopefully now you are able to use the multiplication rules a little bit more to simplify these exponential expressions. All right, see ya.